the series of videos on data science, and today's video is going to be on sine wave model generation and forecasting using LSTM. As you can see on the screen, it's going to generate a sine wave model, and we are going to see how we do this. How to create an LSTM sine wave model using long short-term memory neural network. Some basics of LSTM has been discussed in the earlier videos, and we are going to use this model to predict next value in a sine wave sequence. So the principle of the particular video is that the program uses a special type of RNN called LSTM, which are designed to capture and learn patterns in the sequential data. We already discussed the vanishing gradient problem in RNN has been overcome in the LSTM network. Then a window of past values from the generated data is used to train the LSTM model, and then the trained model is used to predict the next value in the sequence. So first part of the video will be covered in this, and next video will cover the points 4, 5, 6, 7 and 8. So the first point is generating a sine wave data points using sine t. Train and test, that means split the data into 80-20 ratio in like we do in almost all machine learning training. Third part is data pre-processing as part of the LSTM model generation. Further, we will go into the building of the model, then training, then plotting, and give a noisy sine wave. It will generate a clean sine wave from the model. So the complete program is like this. There are a few libraries which are to be used. That's in NumPy, Matplotlib for plotting, math, random, pandas, etc. And you have to use, as I said earlier, the keras for neural networks for the LSTM model, etc. Now, how to generate sine wave model? So first you have to generate sine wave points. So the program, you say n is equal to 500. That means 500 data points you are going to generate. And you can call a function called sine t. Sine t contains certain radians actually. So 3.14 is pi, and 2 pi is going to be 360 degrees, one full wave. So if I create a line space of 0 to 20 multiplied by pi, that means it is 2 pi is one cycle, so you are going to have 10 cycles, as you can see in the picture below. Now, in any LSTM prediction models, you use a concept called windows. The windows are basically sliding windows of 10 values, and you can see in example how windows work. Let's say you have a time series data of 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. That means you have maximum training data of 10. So you can, what you do is first 3 data, when window is equal to 3, first 3 data are taken as a x, and y will be the next projected value is 40. Like this you group them 3 of data, slide the window up to 100. You can have, that means a maximum number of rows is like 1, 2, 3 up to 7. That is calculated as the total number of data in the time series data minus the windows value. That means 7 rows are possible. So you can put them like this in an array with an index. Index 1 I have purposefully written. It is usually 0 to 6. That is like 7 indexes. So x will be 10, 20, 30. Next x will be 40. 20, 30, 40. Next x will be 50. Like that will continue up to 7 rows. The similar concept is used in sine wave also. When you have lots of 500 data, there will be, if window is equal to 10, then you can see that 500 when window is equal to 10. So 500 minus, so In fact, we are going to take 400 data for training and 100 data for testing. So 400 minus window value will be 390. So 390 rows will be there when you have lots of data. So you can see that we are having data up to 0 to 399, that is 400 data. You can up to index 0 to 389, that is 390 rows into 10 columns will be created. This is called a pre-processing. So last is equal to n divided by 5, n is like 500, then is 100. So then x train is equal to x of colon minus 100. That means the first 400 values, this is what it means, will be kept in x train. Then in next text you will have minus 100 minus 110. That means it is like you are going to have 390 data in that. Then the xn is an array. The next text is also an array. So then you have a loop for I in range window length of x train. That means you have I varying from 10 to 399. You are going to create a table of xin from the x train data. This is exactly the concept we said. You are going to create this x and next x. So that is what these lines will do, x in and next. So it looks like that. So we'll create a 390 by 10 columns, and this is how it looks like. Now when I is equal to 0, the next x is equal to x train 10. When I is equal to 11, this will be appended. So you will have an appended values of next to a next x also, which is like a single column going to be. So now you can always print out the length of the x train, which will be 400. Length of the x test will be 110. You can see on the screen. Then data pre-processing for LSTM looks like that. And first convert normal train and test array into NumPy array. You have to convert into, this was looking like 390 rows. Now you have to convert into columns, 10 columns. This is how you do that, rows into columns. np.array xin, next x also you convert into that. So just to show what each row contains, you can see that you can just plot, let's say first four values and try to see, and also you are going to do some kind of shaping. Shaping means you are converting rows into columns. So you can see that before reshaping, these are like 10 datas which are grouped together. First 4 rows only we are showing. We will have up to 390 rows. Dimension is just 2, because this 390 multiplied by 10. This is a 2-dimensional array. And you can say xin.shape 0 means 390, shape 1 means 10. Now once if you reshape, then you are ready to push this into a LSTM. LSTM expects a 3-dimensional data format, and third dimension is now symbol 1. This is because a singular, that is univariate time series. So you are xin is equal to xin reshape. This is like 390 turn 1. So this is the array we are passing, and after formatting how it will look like, etc., you can see in the next screen. See that actual dimension is 3 now, which we are passing into. Shape of the data is 390 10 1. So from 2-dimensional it became 3-dimensional now. And first 5 values, if you try to print it out, see the rows have been converted into columns like this. And this is how we have now gone through the generation of sine wave, testing and splitting the test dataset and train dataset. That is out of 500, 400 has gone into the train and 100 has gone to the test. Data pre-processing before LSTM generation, etc. These parts 4, 5, 6, 7, 8 will be covered in the next video. So that the next video you will see that you will be passing into the model a noisy sine wave. You will see a clean sine wave which is coming out, which is predicted. So you can see that you are going to pass this noisy input, pass through the model, it will predict these two outputs. After first prediction, it looks almost like sine wave, second prediction even better. So you will continue with the next videos soon. Thank you.